All right, so we left off here at 26. What is a buffer? So we described that at the beginning of well, technically the end of lecture 3, but the beginning of the first recording. So buffers are things that reduces major changes, oops, not chances, changes in pH, right? So they keep a solution stable. All right, 27. A something with a pH of 8 would be best described as which of the following? So pH of 8 that falls just above 7. So this is basic. All right. So something that is basic has high OH and low H3O plus. All right, so I think I made a typo in this problem. It definitely wouldn't have high H3O plus, and it definitely wouldn't have no change. It would be A and B, I'm sorry, B and C. But I think your problem on your exam is not going to be double answer. I think I either should have made this also say high or this say low. I probably should have made that say low. Either way, it has high OH and low H3O plus. If it was something that was 0 to 7, right? If it was a pH that was acidic, it would have high H3O plus and low OH. All right, 28. Which type of particles are too large to pass through a dialysizing membrane? That is colloids. These are too large, all right? Things that can pass are ions, small molecules, water, but can't pass colloids, all right? If two liquids are completely dissolved in one each other, this is described as miscible, right? So miscible means the same thing as soluble, which means they dissolve. All right. The opposite of all that, so that answers this question, but let's just say the opposite, just, to flush it all out. The opposite of all that would be immiscible. That means they are insoluble. Soluble. Oops. And they don't dissolve or they don't mix, right? So the example of this one would be oil and water. Miscible, I can't come up with two miscible things off the top of my head. Water and I don't know, vinegar. I don't know. I don't know. But if they completely dissolve, it's miscible. All right, question 30 in a saline solution, which is water or salt and water, sodium chloride and water. What is the solute and the solvent? So the solute is the small amount, what's being dissolved. So in that case, that's the salt. And the solvent is the large amount, and it's what's doing the dissolving, and it's usually always water. Definitely is in this example. All right, 31. Characterize the states of matter. All right, so this isn't a multiple choice. I wrote it weird, but so something that has indefinite shape but definite volume is a liquid. All right, so this is the example I gave you when I talked about pouring out water from a water bottle. If the water bottle says that it's 100 mils, no matter if I pour it out on the ground or if I keep it in my water bottle, it's going to stay that same volume of 100 mils. But it's going to take on the shape of its container, meaning it has an indefinite shape. If I pour it on the ground, it becomes a puddle. If I keep it in my water bottle, it takes on the shape of its container. A definite shape and a definite volume is a solid. All right. I throw the solid on the ground, it's maintaining the same shape. Indefinite shape and indefinite volume is a gas. Gases will take on the shape of their container, but they can also be compressed down. I could take all of the gas in the room, compress it down to like a helium tank or something like that. All right, 32, there is two questions I have to deal with this, even though it seems really simple. So in a chemical equation, say we have A plus B yields C plus D, what's on the right, or I'm sorry, what's on the left is the reactants, all right? Then you have the reaction yield arrow, and then what's on the right is the products, all right? So exothermic is a reaction that releases heat or energy, but usually energy in the form of heat. All right. So exo, you can think of it as being exiting the reaction. And endothermic is a reaction that requires heat. So you can think endo going in. Reduction, we just talked about, its partner is oxidation. And if you remember the oil rig, oxidation is losing, reduction is gaining. So reduction is the gaining of electrons. 35, you only have one question that talks about classifying reactions, but I gave us 5 examples here because I was trying to exhaust all the different classifications we have. Unfortunately, though, I didn't look over this screenshot too much and I gave us a lot of the same. So we have 5 different ways we could classify. We have synthesis, which is also called combination. That's when you have two things coming together. We have decomposition. It's when we have something breaking up. We have single replacement. And then we have double replacement. And then we also had combustion. All right. So go review some other examples in your notes because these examples here aren't exhaustive of all those. But here, this first example under 35, we have lead previously with chlorine, and then all of a sudden lead goes with nitrogen, which was previously with silver. And so this is a double replacement. Here we have two things coming together to become one. So we have synthesis. Here we have another double replacement. Nobody's hanging out by themselves, so they're not single. Here we also have another synthesis or combination. We have two things becoming one. And then here, nobody's hanging out by themselves either, so this is a double replacement. So again, just review decomposition and single replacement in your notes. Don't worry too much about combustion. So 36, what is the simple ion of iodine? It is -1. So this is something you're going to get from your periodic table. So when you print off those periodic tables or you come and get a periodic table the day of, you're going to want to write down the simple ions on the top of the periodic table. So we did this in the last video when we were solving for question 25. All right. '37. So in the last video, when we talked about number 25, I also had us write valence electron trend, which is, at the top of the columns, 1, 2, skip a few, 3, 4, 5, 6, 7, 8. Valence electrons is the number of electrons in the outer shell. So we can use that same trend. If we keep, we get our periodic table, we write it on the periodic table. So let me actually pull up a periodic table here for us to write those back on. Because, okay, where did my periodic table go? All right. So we had Valence electrons, I'm going to write this trend in blue. So that's 1, 2, 3, 4, 5, 6, 7, 8. Then we have simple ion, +1, +2, +3, plus or minus 4, -3, -2, -1. So how many valence electrons does magnesium have? Or electrons in its outer shell? To answer that, 2. Oh, 2. Wrong. Oops, 2. All right. All right, these next two questions. All right, so we have how does the trend of periodic trend of ionization work and atomic size. So these are two of our periodic trends that when we get our periodic table for the why does it do this? When we get our periodic table for the uh for the exam, I want us to write valence electron, simple ion, and then we're going to also draw arrows for these two periodic trends. All right, so we have two periodic trends. As you, let's do them in a whole different color, because why not? All right, so in green, we have ionization energy. So ionization energy increases. So this is ionization energy, and then we're increasing as we go to the right and as we go up. All right. We also have our other trend. We're going to put him in, what's another color? Not yellow, pink. Ionization or atomic radius or atomic size increases as we go down and to the left. All right. So how does the trend of ionization energy work? Right? It increases as you go right and upwards. That's what you need to know about that one. That question just asks you how the trend itself works. The trend about atomic size is going to give you a list of elements, and you have to determine, the order in which their size is. So here we have chlorine, barium, fluorine, and AT, which I'll show you over here on the periodic table. All right, so we have chlorine, barium, iodine, and AT. No, it was fluorine we were comparing. Chlorine, barium, and fluorine and AT. All right, so the smallest, since pink is the trend we're going off of, fluorine's the smallest, then chlorine, and then bromide, with the biggest being AT. So it went fluorine was the smallest. I remember AT was the largest. I honestly don't remember what was the middle. Let me go back. Chlorine and bromide. Chlorine's the next smallest, and then bromide. So chlorine and then bromide. All right. Last page. What are some characteristics of metals and nonmetals? So we talked about where to find those on the periodic table, but just a reminder also, metals are good conductors. All right. They are malleable. They have high boiling points. Yeah, I think this was one of the very first, few 10 slides of lecture one where we talked about I had like a red pot, right? And it was made of metal, and you think of, all of those qualities being like a pot, in my opinion, like a pot you'd put on the stove, right? Good conductors of heat, malleable. You can you can make that certain metal into a pot, right? It's going to take on the shape you want it to. It has high boiling point. Like when you put it on the stove, the pot itself doesn't melt. Non-metals are basically all the opposite. They're poor conductors of heat. They're not very malleable. They have low BPs. They're basically just all the opposite. All right. You're gonna have one question that asks you to locate an element on the periodic table based off of its period and group. So period, this one is just making us find period 4, group 12. So periods are this way. So that might be something you need to write on your periodic table. And then groups are up top. So it was period 4. So it's in this one. And what was it? Period 4, group 12. Ah. Okay, so period 4, group 12 is zinc. All right, so what is the decimal that's on the periodic table? The question isn't actually on your test written like this. This is just kind of the way I wrote it for the review. So that decimal number, right? That is the uh, the atomic mass, but it's the average atomic mass of all the isotopes in basically the world. So focusing on that definition. All right. So um, these words appear frequently on your test, and then one of them you specifically have to know the definition of. So I wanted to just kind of throw them all in here. So solution, right? That's when you have two or more things mixed together. So two or more compounds, elements, whatever. All right, so that's usually referring to some kind of liquid. Compound, that's going to be two or more elements in a fixed ratio. All right, so example H2O, MgCl2. Matter, this is like probably the second or third slide it shows you. This is anything that has mass and, oops, oh man, has mass and takes up space. What is mass? Mass is, you can kind of think of it as like weight, but it's a measurement of volume and like gravity, kind of, without gravity. It's going to be things like grams, milligrams, anything with the prefix of grams. It's how much space something takes up. That's another way of describing it. All right, and then element, this is what we directly find on the periodic table. All right, so like hydrogen, oxygen, carbon, those are all elements. All right, physical and chemical properties. So you only have one question about this, but I wanted to rewrite the question. You know, it's hard for me to rewrite these questions without giving it away. But we said that chemical properties or changes are things that alter the substance. And so some examples of this were things like baking or a bicycle rusting. What else? I don't even remember what else. All right, in physical properties, they don't alter the substance or chemically alter. So the examples, painting a door, trimming a bush. That's really ugly. A bush. Um, Melting or freezing. All right, and then down here, what term, I really should say terms, best describe CO2. This comes down to the like hetero versus homoatomic examples. So we can classify molecules as heteroatomic or homoatomic, and then that describes the layout of the molecules, and then we can describe them as being monoatomic, diatomic, triatomic, or polyatomic. So hetero or homo just refers to how many atoms it has. Or I'm sorry, if the atoms are all the same. So here we have carbon and oxygen. So this is different atoms. So that's hetero. So that's when you have different atoms. If they were all carbon or all oxygen, that would be homo, meaning you have all the same atoms. And then here we describe the number. So carbon, it would be carbon atom and then flanked by two oxygen atoms. So together there is 3 atoms. So it's going to be a heteroatomic triatomic. All right.